Ethereum consensus implementation. And yeah, I want to be in the mood of memes. I love the vibes. It definitely feels like DevCon Prague. So I guess you all know the rationale of why we're here, but we want to keep the decentralization lady happy. And she's not happy. We're making money, but she's not happy. She's not happy at all. So what can we do better? So you know the deal. We have to run nodes. It's important. We contribute to the networking layer in the future to data availability and all this fun stuff. So the current status, Piper describes this perfectly. We have this ecosystem where it's very fragmented, where some players actually run these very expensive full nodes, and then the rest of the user base just use remote RPCs. And then we have this empty area that we want to fill somehow with different use cases to give more choice to the users. So in the future, I see that dApps and at least super users or those that do care about the network and are willing to pay an extra trade-off would be able to fill this space with the technology that we can develop. So, and we are still doing better than traditional finance, just FYI. So here we have seen a lot of initiatives. We are focusing on browser-like clients. So this is what we are going to present. Sorry, I'm turning around because this is not working. I don't see anything what's going on. So the journey of a browser-like client is to first acquire the tip of the chain. We can do that in different ways, but as a consensus implementation, we know that we can do better than just trusting some party. So we're going to explain how that works. Once you have the tip of the chain, in proof of stake, you have to go from that state root, which is proof of stake, and get some useful data that could look like the Ethereum 1 state root or some blob data, and then you go into L2. In this case, we just go to execution layer, which is what we know and love at Ethereum mainnet. And then in EL territory, you get all the fun stuff. You can get state, you can get balances, you can get logs, all the things. So yeah, the first part is get the consensus. Here we do the protocol that Ethan has explained really well. So we have this Altair gadget where there is a smaller subset of validators called the sync committee, where they just attest every block what's the past block. They rotate every day, and it's a small. So thanks to the insane amount of validators that we have and the randomness, this is secure enough, but at the same time, it's small enough that it's pretty cheap to sync, and you don't have to validate all the keys, but just 512. So it's pretty sweet, very light. Then, yeah, this is how they rotate, but Ethan explained better. I'm going to just skip. You can also track the head close. We can run some heuristics, like I show here. If participation drops too much, you can assume that this chain is not safe. But yeah, you can have all these tricks where you can actually track the head with some probabilistic. We can even skip the one block delay if you connect straight to gossip, but then it's going to be a bit more expensive, but that's also an option. Then for EL, now that we have a root, we just do Merkle proofs. From this state root, you can get any data that you want in the state. In the demo, we are going to just show going to the latest execution header. And then for execution layer, same thing, Merkle proofs, prove everything. You can see any data you want. Then this is the journey summarized. It's consensus. It's a honest majority assumption. The data requirements are really low. So this is where I put this label doable, because we can actually build a lot of fun stuff. We can do peer-to-peer today. And it's something that we should go for because it has this honest majority assumption. For CL, because everything is proofs, now we only need someone that gives us data. We can prove that this data is correct, so we cannot be led into an invalid data, but we can be censored. So here, a client-server model with multiple providers, in my opinion, could be sufficient, and the same applies to the execution side. Here I put the hard label because the amount of data that's here is absolutely insane, as Piper knows very well. So yeah, this last section will be taken care by the portal network in the future, being fully peer-to-peer. But so far, we are just doing a centralized model with a client server that, again, can be multiplexed. So you have a bit more resilience against censorship. So yeah, we in Lodestar have developed a REST API, as it has been hinted in multiple presentations, where you can do all of this. You can sync with the proof of stake committees, and then we provide proofs, so you can jump into the execution layer land, and then there we reuse the existing method, the eth_get_proof, to get proof in the state. So these are the routes to do the first, to the consensus. Yeah, I'm not gonna go over them. Then this is the equivalent for peer-to-peer. And yeah. So for the CL, we are using these get proofs. Then for EL, same but get proofs, but this is in execution land. And something cool that I want to bring attention, and I have talking with this with some people, is that we have developed this client that can give you a tip of the chain in a sufficiently decentralized way, then you can get the execution proof. But to do actual fun stuff and replace MetaMask and Infura, that's the dream. We need this middleware logic that converts your average JSON RPC calls like eth_get_balance, eth calls, into something that you can actually prove. So in this diagram, the first section is what Piper is working on, these really cool centralized networks for data provider, but then you need this logic to actually translate the JSON RPC calls into something that you can prove. So what we are working now is into doing that now, and then we can deliver this trustless but censorable RPC that is still much better than the status quo. And it's not useless, because then you can just deliver the portal network faster. So just keep in mind, we can do this. So yeah, my point is we are in the status quo that sucks. We want to go to the portal network land, which is fucking awesome. But meanwhile, we can still do some fun stuff. It's not as sexy, but it's a significant improvement that can deliver value to the users really soon. So we can work on that. Yeah, so my point is status quo, censorable, not trustless. We can go to the right, and we are still censorable, but we are trustless. This is significantly better. So, demo time.
All right, so it's pretty similar to the mycelium demo we saw earlier, but and I think like by now you're probably getting the kind of idea of how the light client is used in practice. You need a trusted root to start. It'll basically bootstrap some small piece of information. We'll progress forward to the head, and then we can then start requesting proofs about the beacon chain. So let's select Kiln, because that's kind of where things can get fun, when we can start doing things on the execution side. So we'll just fill in the trusted root with our own trusted backend. So we're just trusting something right now, but you can fill this in if you go to like the Kiln block explorer, fill in a beacon block, and initialize. Well, that was fast, a little too fast. But so we're synced to the Kiln chain now. And let's see. So behind the scenes, again, we fetched a snapshot. We then fetched updates up to the head, and now we are fetching a new update every single new slot. And then from here, we can select an Ethereum address. What we're doing here is we are using the existing JSON RPC. We're sending a get proof request to an execution backend, and we're retrieving a balance on the execution right now. So this is, it's not the beacon chain; it's all the way down. So this is kind of useful. It's kind of cool. I think like kind of just like generally looking at like what we've been doing here is kind of like incremental progress towards something that can be more and more useful. Like ideally, like later it's like, okay, now then we can hook into libp2p. We can make things more decentralized. We can make it better and better, but start from something that works and then like move outward from there. Anything you want to add?
No, I think you nailed it. Like we are working for something big. We know the goals, but we want to provide value as soon as possible. And yeah, this is our push for this. So.
Just kind of wanted to go over some of just like the considerations that we have working in the browser. So we have some limitations working in a browser context. We don't have access to kind of lower level networking things. It's just what the browser gives us. Of course, when we go into like browser extensions, things get a little bit more. We get a little bit more, but we still have some limitations. So TCP cannot do that. UDP cannot do that. UDP especially, we can't really do that. In an extension, I think you can't open a raw TCP socket. So, but we're not really exploring that right now. Then we get to HTTP, WebSockets, and Web Transport. These are okay. I have a yellow dot here. It's not green because it requires the server that you're connecting to set up SSL certificates. So it's not really like a zero configuration way for a server to like help out. The server the operator needs to do a little additional work. And then there's this thing, WebRTC, kind of this web-specific peer-to-peer protocol. I also have this as a yellow dot because this can work, but there's a lot of caveats to actually making this practical. Like, you need a signaling server, or you may need a signaling server. We're doing some research right now to kind of see if we can remove the signaling server and then allow browsers to directly connect to a server using WebRTC. It's possible. There are some caveats with using WebRTC. It's not usable in browser web workers or kind of in background workers. It's only available in a main thread. So it's not great for all browser applications, but it's kind of workable. It's yellow. Some questions we're asking, are you going with a client-server model? Are we connecting to a peer-to-peer network? We can do both. We're starting with client-server. It's easier. Peer-to-peer is great because maybe there's more peers on a larger network. But maybe then we need to figure out how we're discovering those peers. REST, that's what we're starting with. It's easy. It's very easy to just add a new endpoint. But it may be limiting in the sense that you have to now configure specific servers that you're connecting to. libp2p, yeah, that would be great, except the current consensus spec only has a must for the TCP transport, which is not expressly browser compatible. So if we actually want to make that practically more useful for the consensus network, we would want to add additional transports as maybe shoulds or something in spec. And then DisV5 portal, it's a UDP protocol. We are kind of limited there, but the ultralight team has been working on a proxy, a really thin kind of proxy, and passing things through a proxy then kind of opens up the world of portal and DisV5. So there's challenges, but we're kind of working on things and making incremental progress.
Let's go. Thank you. So yeah, we really hope to collaborate. Thanks for all the awesome initiatives that have been so far. Shout out Snowbridge. I think they couldn't join here, but they are also using this technology. And Shield Time. So yeah. Lodestar. We do like clients, but our main job is we have a consensus client. So if you're interested in joining or running it, we are in production. We're doing nodes. Everything is going fantastic. So if you want to contribute to diversity, please consider running Lodestar. Yeah, also these 4 updates on Lodestar. And yeah, there is a party tonight sponsored by ChainSafe. So if you want to join, you can. Just use the promo code. I think everyone in this room can enter. So yeah, thank you so much.